Okay, friends, we're going to take a look at our second lesson of related rates. Really a rich chapter to practice many of your curricular competencies, especially with active learning, with communication, reasoning, reflection, and problem solving. So let's press into that as we do and be ready to take um, note of areas where you have grown. So you should have your digital portfolio cheat sheet in front of you so that you can be looking at looking at your curricular competencies as you practice. Alrighty. So let's take a look at first people's principles here as we're looking at what will be some very challenging problems. And I just want us to hunker down um, on perhaps recognizing that learning takes patience and time. So if your expectation is that you're going to get this instantly, that's going to cause a lot of pressure. And we need to slow down and remember that learning involves patience and time. Other things that we just need to recognize, maybe this one, learning involves recognizing the consequences of our actions. So oftentimes what can happen is, we get behind, we're not up to date, and then we start saying things like, I'm not very good at this, or this is too hard, or we make other excuses other than recognizing there are consequences of not finding the time and space. And we just need to be more accurate with the way that we look at what the reality is. And if we're short on time, we're going to be short on understanding. And when we get back to this motto, which is learning involves patience and time, then we can start filling in those gaps. So today, maybe those would be things to be thinking about. Okay. And also just this, whenever we face challenge, we're going to get a chance to explore who we are as people. What helps us stay in the moment, what pushes us into the past or too far into the future, and let's help us stay in the present. So really, as we're learning, we can be looking at who we are as people. We can remember that learning takes patience and time, and we know that the way when we do one thing, it impacts us in another way. So everything's connected. And these are so good. Learning is holistic. We're all made up of many different pieces. We're not single dimensional. We're 3D in so many ways. So just keeping that in mind is really helpful. Okay, let's take a look at this. 4B. This is really closely connected to 1B and 3D. Visualize to explore and illustrate mathematical concepts and relationships. Create, use, and communicate mental images to demonstrate understanding. And to do that, of course, we're going to use our voices, text, technology, drawings, manipulatives, diagrams, and modeling. We're going to be working on that. And our evidence that we use for 4B could look similar to 1B and 3D. So please keep that in mind. Okay, so today, once again, our goal is to be working on our ability to draw pictures. So to take a context or a situation and turn it into a meaningful drawing. And we're defining a meaningful drawing as one in which if we erase the question and we look at the drawing, if you're able to answer the question from your drawing, then you've drawn a good drawing. Okay, so we're still very much beginners with related rates. So most of us would be sort of at an emerging and developing level. And so let's get into it. Okay, this is a warm-up question. Really important. For how much time is the water 2 meters tall? For how much time is the water 2 meters tall? So let's suppose this is 2 meters right here. For how long is it 2 meters tall? This is an important observation. Hope you're thinking that it's just for an instant. So it is only for an instant. You can see, like, here's 2 meters right here and there, and it's gone. Okay. It's another warm up. Let's see how we do. A cone has a height of 5 meters and a radius of 3 meters. Determine the radius of the smaller circle. So determine the radius of the smaller circle when the water is 2 meters. Okay, so this is a really, really important question. The first thing that I'm going to do is set this up and call that radius 3, and I'm going to call this radius here 5. Can you guys tell that, let's say we're trying to find out this radius here, and when this distance here is 2. So if this distance is 2, how would we find out the radius? Okay, strongly recommend taking this and redrawing this. So I'm going to draw 2 pictures here. I'm going to draw a big triangle here with a 3 and a 5. And then I'm going to draw a smaller triangle right here with a 2 and an R. Okay, and so again, what we're going to do is obvious. Hopefully, it is plain to you to see that these triangles are similar. Both have right angles. Both have the same base angle. So we know for sure that these two triangles would be similar. I'm having trouble with my mouse right now. Okay, and because they're similar, we know that we would know that R over 3 has to be the same as 2 over 5. And I can simply multiply that, and I can multiply there. So that would be 6 divided by 5 is 6 over 5. Okay, let's look at my PowerPoint and see if that provides another way of thinking about it. Okay, so again, similar triangles will be a key to your understanding today. So let's take a look at my PowerPoint. So this is 5. We're comparing 5 to 2, which are the two known heights. And then here's our triangle. 3 by 5 has to be the same as R by 2. Okay, and so we can set this up height over little height over big height, little r big R. There's a lot of ways we could arrange this, but I chose to go height to height, rate to rate. I'm saying that 2 over 5 has to be the same as R over 3, and when we multiply the 2 by 3 and divide by 5, we get 6/5. Just to make sure that we're clear on the mathematics there. You know how cautious I am just to use patterns unless we know what we're doing. If we wanted to isolate here, we'd really be multiplying both sides by 3, and so those would cancel, and 3 times 2 is 5. Sorry, 3 times 2 is 6, divided by 5 is our 6/5. But also we could have just used this great pattern here, multiplying the diagonal and divide by what's left over. So that is a warm-up question for the problems that follow. So stay in the problem, stay curious, and let's go. Okay, so here is the question. A water tank is built in the shape of a cone with a height of 5 and a diameter of 6 at the top. Water is being pumped into the tank at a rate of 1.6 meters cubed per minute. Find the rate at which the water level is rising when the water is 2 meters deep. Just a quick question. When is the water height moving the fastest? Is it moving? Is it rising at the same speed? And I hope you can tell that it's moving fastest at the bottom here, where the cone is smaller. But then as we get wider, it's slowing down. So that's really important because the rate of change of the height is going to be changing all the way along. So when the water is, say, 2 feet deep, it's going to have a different rate of change than if it was 3 feet deep or 4 feet deep. So keep that in mind. Notice that we've given you this formula, and notice also here that we have a number of variables. We have a volume, we have radius, and we have height. So those are important. That's important to note. For this one, I'm going to jump right to the PowerPoint. So I'd like you to try this. I'd like you to wrestle with it. I'd like to see how far you can get in it. If you just jump directly to my solution, while that may help you learn this one individual problem, it does not help you with problem solving. It doesn't help you with perseverance. It does not help you with visualization. All it does is it helps you learn how to do this singular problem. Okay, and if you're short on time, maybe that's all you can do. But if your goal is to shape and change your brain, then I want you to give it a good 20 minutes before you look at my solution. All right, so pause the video and see how you do. Okay, step 1 here is to really draw a really, really great picture, okay? And so what we're going to do is ask ourselves if we know what the volume is, which we don't. From the question, we know that it's changing at 1.6 meters cubed. We don't know what the radius is at that particular time. We don't know what the rate of change is. And we also we do know what the height is at a specific moment. Notice I put an asterisk there, which means that we can't input 2 into our equation until we've taken the derivative. That's a really important why. Okay, and the why for that is if we put 2 into our equation, which is 1/3 pi r squared h. If we put 2 in right now, that would mean that the radius isn't changing, and we can see that it's changing. The radius is getting bigger at every moment. So this question is asking at a particular instant in time, when the height is 2, what's the rate at that instant? And that's why we can't put it in there. Something to notice here is we don't know radius or height, and this is what we're trying to find. We're trying to find h prime here. Okay, this is a really important thing to do before you start looking at equations. Okay, so because we don't know anything about the radiuses, and we have the h, and the question is the height, what would be a really good idea here is if we could get rid of the radius. In other words, write the radius in terms of height. So that's what I'm going to do here. And this is a tricky piece of this question. Okay, so what I'm going to do is say that 3 compared to r must be the same as 5 compared to h. So h over h equals r over r, and so h over 5 has to be the same as r over 3. So I'm going to isolate for h, so multiply both sides by 5. And by isolate for h, I mean isolate for r, excuse me. What we want, you'll see why we do that in a sec. We want to get rid of h. We want to write r in terms of h. And here's why that's helpful. When I come to here, all I'm going to do is I'm going to sub that in for r. And when I do that, we'll have only h's here. So when I simplify this, this will be 9h squared over 25. 9h. So this is, remember, this is going to be 9 on top, 9 times 1, and then we'll have 3 times 25 is 75. So here's what the volume, v prime, is now, or volume is. This is such a straightforward derivative to take, which you're going to take. So we're going to bring down the 3 by the power rule, and then remember, then we're going to say, how is h changing as time changes? So remember, this is actually dv dt and dh dt, but we've used the short form, which is my preference. And then we're just going to fill it out from the information that we have here. Okay, so we're going to insert the variable. So 1.6 was the rate of change for the volume. We're going to put in 2 finally for the height, because that's what we're trying to find, is what's the rate of change when the height is 2, and then we'll rearrange it and isolate for h prime. Okay, so clearly a very tricky question. Either of those would be fine as solutions. The trick here is when let's go back to our original question, is to really start off with the formula, look at the information given, and let that be the guide. So we're going to start with that equation, okay, and which was volume equals 1/3 pi r squared h, and we're going to write down all those variables: v prime, r prime, h prime. We're going to fill out what we know. We noticed that we didn't have any information about r, so wouldn't it be great if we could get rid of r? And that's what we did. That's what motivated this move here, okay, which was to try to write r in terms of h. And so when we did that, then we could take that and replace r with the h value, which we did, which then made this a very simple derivative to calculate. You can see with related rates that the thinking, so this is thinking, this is thinking, this is thinking, this is the hard part. The derivative is the easy part. So hope that went well. It's a tricky question. Hope it helps. Okay, we're going to take a look at one more, which is also going to be quite tricky. And here we go. So a spotlight on the ground shines on a wall 10 meters away. So let's see how this goes. Let's see if we can get started on a drawing for this. The drawing is essential, so don't even attempt anything until you've drawn something. So I'm going to do this. I'm going to draw. There's my wall. I'm going to label this W for wall. There's a spotlight. Okay, and I'll even get a little bit of yellow on here. Oh, that is not yellow. This is yellow, and it's shining onto the wall. Okay, then it says a man is walking. Okay, here's the man. He's like this, and he's walking. Which way is he walking? He's walking. A man 2 meters tall walks from the spotlight toward the wall. So he's walking this way. Okay, and he's walking at a particular speed. So I'm going to call this x. The x meaning the distance between the man and the wall. And I'm also going to call x prime. This is the speed that he's walking at. He's walking at 1.2 meters per second. Okay, how fast is his shadow on the wall decreasing as he gets closer? So hopefully you can visualize that. As this man walks closer, that shadow is going to be going down. So we're going to be expecting a W prime that would be negative. So this is what we're trying to find. Okay, it does not tell us how. It tells us what. So if I were to write this down, I'd have that. I don't know what x. I know what x prime is. It's 1.2. And that would be a decreasing value because it's while he's walking away from the spotlight, his distance to he's walking toward the wall, so we're going to call that a decreasing value. And then we're going to have x is when he's 3 meters from the wall, and we're going to put an asterisk by that. Okay, this is a tricky question. Okay, so let's make sure we have all of our information. So we have this, there's this, and let's just make, I missed a huge piece here. That this distance right here is 10. That is really, really important. I was honestly, I was starting to panic there because I was aware that information was missing. Okay, so a spotlight on the ground shines on a wall 10 meters away. A man 2 meters tall walks from the spotlight toward the wall at a speed of 1.2 meters. Okay, so let's just look at this again. So this distance is 10. We're calling this height wall. We know the wall prime is the question. We know what x equals at a particular moment in time. And we also know the speed at which it's going. At this point here, this has enough information to answer the question. Okay, so what I'm going to do is clear this screen and look at the PowerPoint on the next slide. Okay, so there's that picture. And you can see they're using the H and H prime rather than HW, or H rather than W, which is fine. We're using W prime here as the walking speed, I guess. And it's 3 meters. So we're trying to figure out how quickly is the height changing down the wall when they're 3 meters. Okay, this is the tricky piece. Is we're going to draw 2 triangles. Okay, and you should pause right here. If you aren't doing this on your own and you're just watching this video, you should be doing it on your own, because what we're trying to develop in you is a problem solver, not a problem follower. Okay, so really give your brain a chance, and you don't have to get the whole thing, but you have to like put a good chunk of time in if you want to develop these stretching competencies in reasoning and problem solving. Okay, so here's a triangle. We got an H. By H is the height, and 10 is the width. Now notice this. I'm going to call this distance here W, and this height 2. So this is the man's walking speed, but this is the distance W, and as this grows, we grow at W prime, so this distance is W. Okay, so what we can do is we can create a little, and we know the walking speed, and we know that distance there, and we know that this distance must be 7. I can't put 7 in for W right now because remember the person's moving, so we're trying to determine a rate when it's 3 meters away. That's why there's that asterisk there. So I hope you can see that these 2 triangles are similar. Obviously these would both be the same, 90 degrees. These 2 would be the same because they're the same inside the same triangle, and the third angle in a triangle is equal if the other 2 are equal. So now what we're going to do, and also we noted all this information. This would be important. So draw the picture and state these pieces. I don't know what H or H prime is. Using similar triangles is going to be a good move. Look at this. It's really going to be the height over 2. So height over 2 has to be the same as 10 over W. And remember, we are trying to find H prime. That's what we're trying to find. So all I'm going to do is rearrange this and make it H equals 20W to the negative 1. Now we're going to take the derivative of that. So we're going to have H prime equals negative 20 W to the negative 2. And another way of writing, and remember, we need to take the, it's a chain rule, and we're going to ask, how is W changing? Is time changing? That's why we have that W prime there. Another way of writing it is that. So with the negative, the W to the negative 2 on the bottom. And so all we're going to do is take the 20, and we know what W is because we wrote it down. It's right there. We can put the 7 in there, and you simply calculate. Obviously, a really tricky question. Let's just recap some of the things that we did there. Okay, so the first thing that we did is we would have drawn this situation here where this is 10 and this is the height, and then there's this man and they're at a height of 2, And so can you see that we have two triangles, and we can compare height to 2 and 10 to W. That's what we did. And so as you walk through that slide deck, that PowerPoint there, you can see that. Okay, so we have just one more challenge to look at. And again, this is fairly basic. Let's take a look at this. So given x squared plus y squared equals 33, determine the value of dy dx when x equals 5. So this is just going to be implicit differentiation, and you can see that we're going to have 2x plus 3y squared times y prime equals 0. And then we're going to put 5 in for x. We can figure out what y is because we can put 5 in right here. So that would be 5 squared is 25. 33 minus 25 is 8. Therefore, y must equal 2. So we can put 5 in for x and 2 in for y, and we can rearrange this, rearrange it and solve for that. Okay, so that was a very quick explanation, but I think that's something that you can handle. Okay, so this is implicit differentiation from here to here. We can put the 5 in right there, but when we're stuck on the y, we'd have to put the 5 back in here to figure out what the y value is. And once we have the y value, we simply go and put it there and there. Whoops, we just put it where we see the y. Okay, so this one's a bit more tricky, or different anyway. This one says given x squared plus y cubed equals 33 and dy dt equals 3, determine the value of dx dt when x equals 5. So again, this time we're going to be taking the derivative of this with respect to t. So when we take its derivative, you can see here it's going to be 2x x prime plus 3y squared y prime equals 0. And look, this time it's going to be similar. We're still going to put 5 in for x. We're going to put 5 in here, x, to find the y value, which is 2. So we're going to put 2 right there. Oh, sorry. We're going to put 2 in for y. And then we know that dy dt from the question is 3. So we're going to put 3 in for dy. So that's what we see. So 5 was given. The 2 we could find by putting 5 into the equation. 3 was given, and now you're going to rearrange this equation to find dx dt. Okay, so and there you go. So friends, this is the second lesson of related rates. The first day we focused on Pythagoras. The second day we focused on similar triangles. And this gives you a good taste for some of the challenges that you're going to face. Starting off with a very good drawing is the first step. The second step is making sure you're listing and labeling the variables very well. And the third step is filling it out. All right, so there you be. I hope you can see how important it is to take a perspective that we learned from the First Nations people, that learning takes patience and time. If you expect to get this right away, this will cause great stress for you. Okay, and so remember that learning ultimately should be taking care of the well-being of ourselves. So when that's not happening, we need to stop and pause and do things like wonder, who are we? And notice that the consequences of our action, there are consequences to our actions, even good ones. So if we have too many things in our life, the consequences of that is not having enough time, and not having enough time leads to the feeling of being unprepared, and stress soon follows. So really a good thing to consider as we are learning and moving through life. Okay, and once again, for evidence that you will be able to show in time will be your ability to take your mental images and represent it in many ways, which is also closely connected to reasoning, which is your ability to model and take contextual situations and turn them into meaningful drawings, and from there into equations, which are symbols and number, and of course 1B as well in your communication piece. So they're very closely connected. Anyhow, I think we'll stop there. If you have any issues, please come by and see us, and here's a form to fill out if you have any questions. So this concludes our clip, and I hope it was helpful for you.